case of digital electronics subject, we are going to discuss about adders and subtractors in this video. We'll be discussing about half adder, half subtractor, and also full adder and full subtractor. Okay. And also I'll be giving you some additional information regarding how to construct a full adder using half adders and also full subtractor using half subtractors. Also, we'll be discussing in this video. Okay. So let us discuss about adders and subtractors. This is a quick revision video. Okay. So if you are seeing ECE Electronics channel for the first time, please do subscribe to the channel for subject related videos and recruitment updates. Also follow us on our Instagram page. Let us discuss about adders. So adder is a combinational circuit. So a combinational circuit means this circuit doesn't having any memory element. So whatever you are going to give the input, it will be taking that input and it will be performing some operations on the input and it will give you the result. So it doesn't have any memory element. That is the main difference between a combinational circuit and a sequential circuit. Sequential circuit is having memory elements. It will be depending on the output, the past outputs also. But here in combinational circuit, at any instant, it depends on only the inputs. Okay. So that is a main feature of a combinational circuit. Let us discuss about the adders. First is half adder. So this is a circuit diagram of a half adder. There is two inputs A and B. There is a sum and also a carry. Okay. So if you take the case of a half adder, it is actually a combinational circuit which is going to take two inputs and it will give you two outputs. The half adder circuit is designed to add two single bit binary numbers. Okay. Two single bit binary numbers it can add and it will give you the result. So it is having a basic block. This half adder is having a basic block which is going to add two single bit numbers. The outputs are sum and carry. Okay. So two single bit numbers it is going to add and give you the results. The results are sum and carry. Okay. Next, let us see the inner circuit diagram and also the truth table. So this is the truth table of a half adder. So the inputs are A and B. There is A and B are the two inputs and the outputs are sum and carry. S is indicating sum, C is indicating carry. So if you are going to give 0, 0, sum will be 0, carry will be 0. 0, 1, sum will be 1, carry will be 0. 1, 0, sum is 1, carry is 0. 1, 1 if you are going to give, the sum is 0 but the carry is 1. This is going to be the case. This is going to be the truth table. Now if you write in terms of a logical expression, the sum can be written as if A and B are the inputs, then sum is A XOR B. Now how will you get this expression is by drawing the K-map of, or if you simplify for the column of sum, you will get this expression which is called A XOR B. Next, carry, the logical expression is A and B. That is, if you perform the AND operation of the two inputs, you will get the carry. Now you can draw the logical diagram using this logical expressions. Sum S is equal to A, B, it is given to a XOR gate. Okay. So that's why we have written A XOR B. Carry will be AB, it is given to a AND gate. So AB given to the AND gate, then it will give you the result of carry. Okay. So this is the case for a half adder. Next, full adder means full adder is actually developed to overcome the drawback of a half adder. Okay. So half adder can only add two single bit numbers, right? Now in the case of a full adder, it can add two 1-bit numbers A and B and a carry. Okay. The full adder is a 3-input combinational circuit and a 2-output is also there. That is 3-input, 2-output combinational circuits. So let us see the diagram of a full adder. There are 3 inputs A, B and carry in. The result is sum and carry out. Let us see the truth table and the circuit logical diagram. So the truth table is there are 3 inputs and 2 outputs. The combinations that we are going to give is 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0 and 1, 1, 1. And the sum is going to be for all zeros, that is all 3 zeros if you are going to give, sum is 0, carry is 0. For 0, 0, 1, sum is 1, carry 0. Then 0, 1, 0, sum is 1, carry 0. Then for 2 ones, that is 0, 1, 1, sum is 0, carry 1. Again 1, 0, 0, sum 1, carry 0. 1 0 1, sum 0, carry 1. Likewise, it will go on. So wherever you are seeing two, that is even number of ones, then the sum will be 0. Here you can see there is odd number of ones. So in that case, sum is 1. Here you can see even number of ones. So the sum is 0. And also for all 0 case, the sum is 0. Carry also, whenever you are seeing even number of ones, there will be a carry. And also when you are here for this case, that is 1 1 1, here also there will be carry 1 generated. Okay. So when you are giving all ones as inputs, sum will be 1, carry will be also 1. So this is going to be the truth table of a full adder, and the logical expression is, for the sum, the logical expression is A XOR B XOR carry in, that is C in. Carry out, the expression is A dot B plus carry in into A XOR B. Okay, now we can realize this expression as a logical circuit diagram, and you will be getting A, B, C in. This is carry in, okay, and this is carry out. So A, B and carry in is given to this circuit, and how there are actually two XOR gates and two AND gates, and then there is one OR gate, okay, and the sum is obtained as an output of this XOR gate. So here if you see this XOR gate, first we are going to take the XOR of A and B, and this will be the output. So we are going to give A and B to the first XOR gate. The output we are going to give to the next XOR gate along with the carry in. Okay. So then you will be getting your sum. Just like we have written here, A XOR B XOR C in. So that operation will give you the result of sum. And the carry in we will be getting with this expression. Okay. So this is going to be the expression for carry. Okay. So just remember these expressions, that is sum equation and the carry equation, and you can draw this diagram. Okay. Next, comparison between a half adder and the full adder. Half adder is actually a combinational circuit which is having, or which can add two 1-bit numbers, and half adder produces sum and sum of two inputs. Okay. Half adder can only add two 1-bit numbers, and it will be producing the sum of these two inputs. Full adder is a combinational circuit that can perform addition of three 1-bit binary numbers, and the full adder produces the sum of three inputs and carry value. Okay, that is, it is producing the sum of three inputs and also a carry result. Here also you will be getting a sum and a carry, but here the difference is that you can give three inputs, A, B and carry in, that is two inputs and along with the carry. Then here for the case of half adder, previous carry is not used, but for the case of full adder, the previous carry can be used. This carry out can be again given to another full adder as a carry in. Okay, so carry can be reused, or it can be used. Next, in a half adder, there are two inputs A comma B. Then in a full adder, there are three inputs A, B and carry in. The logical expression for sum is A XOR B, carry is A and B, that is A dot B. Here, sum expression for full adder is A XOR B XOR C in. Carry out is AB plus C in into A XOR B. This is the expression. I have also written that here. Okay. Just by heart these two expressions for half adder and full adder. It will be very useful. Okay. Now, for the case of half adder, it consists of one XOR gate and one AND gate only. Very simple diagram it is. We'll see that. See, this is the circuit diagram for a half adder. There is only one XOR gate and one AND gate. But for the case of full adder, it consists of two XOR gate, two AND gate and one OR gate. We'll check that also. There are two XOR gates, two AND gates and one OR gate. With the help of these much of gates, we are going to realize a full adder. Next, where are we using these two adders? Let us see. It is used in calculators, computer and digital measuring devices. Now here, it is used in multiple bit addition and digital processors. Okay. So that is the comparison between a half adder and a full adder. Okay. So especially if you're preparing for any competitive examinations, this will be very useful. That's why I've included. Okay. So we have seen the expression for half order, that is expression for sum and carry of half order, and also we have seen the expression for sum and carry of full order also. Also we have seen the truth table and the circuit diagram. Okay. So this much of information is enough if you're preparing for a competitive examination point of view or a semester exam point of view. If you are seeing, you should at least study this much of things from half order and full order area. Okay. Next, let us move on to the next section of topic, which is half subtractor and full subtractor. Half subtractor means here you're going to take two inputs. You're going to generate a difference and a borrow out. Okay. So this is the truth table and the next, we are going to see the truth table and the logic circuit diagram of a half adder. So in the truth table, you can see that there are two inputs A and B, and there is a difference. Here we are taking A minus B, okay, and then the borrow, okay. So if we are giving 0, 0, then A minus B will be 0, 0, 1, A minus B will be 1, and there is again a borrow, and 1, 0, A minus B is 1 and borrow is 0, 1, 1, difference and borrow both are 0. And the logic circuit diagram is like this. A and B is given to an XOR gate, and difference will be A, it is not plus, it is XOR B, okay. And the borrow is actually, there is only one value and it is for A bar B. So A bar you are going to give to this AND gate, and then B we are going to give this to this AND gate, okay. So it is borrow is equal to A bar B. This B is indicating borrow, okay. Borrow is A bar B and difference is A XOR B. Next, let us see the case of a full subtractor. Full subtractor will be taking three inputs A, B and a borrow in. And the output, there will be two outputs, difference and borrow out. Let us see the truth table and then we'll be seeing the diagram. Okay. So for the truth table, we are going to give three inputs A, B and borrow in. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1. Likewise, we'll be giving up to 1, 1, 1. The difference, you can see that here for 0, 0, 0, difference is 0, borrow is 0. For 0, 0, 1, the difference is 1, borrow is 1. Here you can see you are having only 1, 1. The other values are 0. So it will be difference 1 and borrow 1. Then again, if you are having 0, 1, 0 means again you are having difference 1, borrow 1. Here you can see that A is having a value 1. So if you are going to take A minus B in, again A you are having 1. So it will be difference is 1 and borrow is 0. Okay. Here you can see you are having 0 minus 1 minus 1. Okay. So here in this case 0 minus 1 you will be getting difference is 1, borrow is 1. But that difference you are going to subtract with the next number. So you are taking a 1 minus 1. So the difference will be 0, borrow will be 1. For the case of 0, 1, 1 I am talking. So here we are actually performing 0 minus 1. Then the result we are going to again take, and again we'll subtract a 1 from the result. Okay. So hence we'll get a difference 0 and borrow is 1. Likewise, we'll take for all the values. For the last case, that is when we are taking 1, 1, 1. See here, first we are having A and B are 1, 1. So 1 minus 1, you will be getting difference 0 and borrow also 0. But again, the result you have to again take the difference with B in. Okay. So you will have a 0 till this you have a result 0. That 0 you are going to again take and subtract a 1 from the 0. So 0 minus 1 again you have to perform. So 0 minus 1, difference 1, 0, sorry, borrow also 1. Okay, likewise you will be performing the, that is you will be performing the operations with all the input combinations in the truth table. And while performing the operations, you have to remember these rules. I'll show you the rules. See, these rules you have to obey. That is 0 minus 0 will be, the result will be 0 and borrow is 0. 0 minus 1, the result is 1, borrow is 1. 1 minus 0 is result, that is borrow, difference is 1, borrow is 0. 1 minus 1, result 0, borrow also 0. So this 4 rules, these are actually the rules of difference or subtraction of operation that you have to obey while doing the truth table. That is while looking into the truth table of a full subtractor also. I'll explain it once again. 0 minus 0 is a minus b. If you are taking, it is 0 and borrow is 0. 0 minus 1, you will be taking, that is you will be getting a difference a minus b as 1 because you are taking 0 and you are going to subtract 1 from the 0. So you will be getting difference is 1, borrow also 1. 1 minus 0, difference only 1, borrow is 0. Then 1, 1, difference 0, borrow also 0. Okay. This also you have to keep in mind while taking that is every cases or every conditions for this truth table. So what you have to do is first take the value of A, subtract B from the value of A, then take the result, subtract B in from the result. That we are going to do here. Okay. Next, the difference expression is A XOR B XOR B in. That is the difference expression. Borrow out expression is A complement B in plus A complement B plus BB. This is going to be the expression for borrow out. You have to study both the expressions. Okay. Next, this is going to be the diagram of a full subtractor. Here we are using two half subtractors and a OR gate. Okay. So B in is given to the half subtractor. Then A and B are given to a half subtractor. The result we are going to give to this half subtractor. Then from the output of the half subtractor, you will get a difference. And the results of there is this value of the borrow of this half subtractor, and this value we are going to take to OR gate. Then we will get a B out. Okay, so this is going to be the diagram. You don't need to by heart this diagram. Just study this logical expression and automatically you can draw it. Okay. So for exams and all, you don't need to draw the circuit diagram. You only require this expression. Okay. So expressions you try to by heart. At least you try to, if you are not good at by hearting the things, then study this truth table and you can automatically, that is you can by your own, you can draw the K-map and find the expressions for the difference and borrow. But it is a lengthy process. It is a time consuming process. So the easiest thing is to study these two equations by heart. Okay. Next, again you can have another realization for full subtractor. Actually we have in this diagram we have used two half subtractors, right? But if you are using all basic gates, you can go for this diagram. You are going to take A, B, C. So this is given to a XOR gate. This is an XOR gate. So the difference will be A XOR B XOR C. Okay. I have used C here. The variable name I have used as C in place of B in. You have to think this C as borrow in. Okay. So A XOR B XOR borrow in. This is the expression. Okay. This is the expression, same expression we are using here. And this is the realization for the carry out. Okay. Next, let us see how can we realize half adders. That is, how can we realize full adders using half adders and full subtractors using half subtractors. So this is how you draw this is a full adder circuit diagram, and you can realize the full adder using two half adders. This is the first half adder, this is the second half adder, and a OR gate. Okay, this is how you draw it. Next, full subtractor also can be realized with the help of half subtractors. So this is first half subtractor, this is second half subtractor, and again with an OR gate you can realize a full subtractor, because I've seen a lot of competitive examination questions regarding the same. How can you realize a full subtractor using half subtractors? How many half subtractors you require, and what is the combination of the elements you require to realize a full subtractor? So you have to pick two half subtractor and a OR gate. Okay. So likewise for full adder also you can realize it using half adders. So in this video we have discussed about half adder, half subtractor, full adder and full subtractor. Also we have done a comparative study for the half adder case. We have seen all logical expressions and logical circuit diagrams. So this was actually a quick revision video of the adder and subtractor topics. Again, there is further different adders are there. Ripple carry adder, carry look ahead adder, various type of adder, carry bypass, various adders are there, that we'll be doing as a separate video, as a single video we'll be doing. And all those adders will be doing as a single video. Okay, so it will be actually useful for your preparation if you're preparing for your semester exams or for some competitive examinations. So if you are preparing for competitive examinations, mainly this topic, that is half adder, full adder, half subtractor, full subtractor, this area or this topic you have to focus on. Okay, so I'm really hoping that you found the video useful. If yes, please do give it a thumbs up. Also share it with your friends, and if you want more videos, please do subscribe to the channel. Thanks for watching and keep on watching.